Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. So I am welcoming you all to this beautiful online learning platform once again. Now we are happy to announce that Unacademy is going to providing online training for GATE and engineering service exams. GATE and engineering service exams. Okay. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE exam. At present, I am pursuing PhD from JNTU Kakinada. Okay, and my specialization is VLSI design. Now here we check how to get Unacademy learning app. Just go to Play Store, type Unacademy. Then it will shows the Unacademy learning app like this. By clicking on this install button, it will install the Unacademy learning app into your device. What you will get? Yeah, this is very important point to you. So by joining this Unacademy, what you will get? See this. First and foremost thing is daily live classes. Every day you have a live class. After that, structured courses, live tests and quizzes, unlimited access. Okay, these things you are going to get it. Now, if you observe the daily live classes, every day you have a live class. The intention to conduct a live class on every day is always to keep the student in touch with the subject. Always to keep the student in touch with the subject. With that intention, we are conducting live class every day. Okay, in that class, you can chat with your educator and you can engage in discussions. You can ask your doubts and you can answer the polls. All these things are, you can perform all these things while class is going on. In live class itself, you can do all this. And after that, structured courses. So all our courses are structured in line with your exam syllabus to help you best to prepare for it. Okay, whatever the exam syllabus you have, that exam syllabus is well structured for your course. Then it is easy to you for your exams preparation. After that, live tests and quizzes. In that, you can evaluate your preparation with our regular mock tests and quizzes and get the detailed analysis on your performance. Okay, so to evaluate your preparation, whatever the online regular on mock tests and quizzes we are conducting, by participating in that, you get your detailed analysis on your performance. And after that, unlimited access. So once you take a one subscription, you get access to all our live and recorded courses. Live and recorded courses to watch from the comfort of any of your device. Whatever the device you can use, either tab, mobile, desktop or laptop, whatever the device you can use, choice is yours. Okay, these are the things you are going to get it. Next, there are two subscriptions, iconic subscription and plus subscription. In plus subscription, just before, what are the things we discussed? Daily live classes, structured courses, live tests and quizzes, unlimited access. All these things you get from plus subscription. In iconic subscription, you get what are the benefits got by the plus subscriber. All those benefits you get. In addition to this, you get personal coach, study tracker, mains question and answer practice. in personal coach, here you get one-on-one guidance from top exam expert. One-on-one guidance from top exam expert. The top exam expert is your personal coach. So once you written the exam or you attempted a quiz that is analyzed thoroughly by your personal coach, based on your performance in that exam, they will prepare a proper study plan and respective study material also they will forward to you. That is the function performed by the personal coach. After that, study tracker. So by participating in study tracker plan and study booster workshops, you can evaluate your progress in weekly reviews with personal coach. So you can participate in study tracker plan and study booster workshops. Okay, by participating that, you can evaluate your progress in by weekly reviews with your personal coach. And the most important thing is mains question and answer practice. So in your engineering service exams mains paper, you need to answer the question in a descriptive way. So you need a regular practice for that. The way how you are answering in your semester exams is different and the answering in mains is different. Okay, in mains exam some points we need to stress, some points no need to give importance to that. Okay, where you have to give importance, which equation we have to use. Okay, and in that equation which point we need to stress, everything you need to get a more practice, you need to take a more practice. Okay, so you can strengthen your mains answer writing through regular practice. Okay, with the and we evaluate that and give the personalized feedback to you. We analyze that, we evaluate it and provide a personalized feedback to you. These are the things you are going to be getting. So this is the mains question and answer practice. Okay, so these are the things you get in description in the plus and iconic subscriptions. After that, Unacademy combat. Yeah, now there is Unacademy combat is going on. It is the India's free scholarship test for GATE and engineering service exams. Now the worth of scholarship test is 3.5 plus crores only in the month of April. Only in the month of April. Okay, and participate in that and get the scholarships. Now this is on every Sunday in the month of April. These are the departments: mechanical engineering, civil engineering, electrical, electronics and communication engineering, computer science and IT departments. For these departments this combat is going on. Now 18th is already completed. Now next coming Sunday 25th you have the exam. Don't miss that. Use my code VIRAO10 during enrollment. Now in that, prizes. So top 3 winners from this exam from each branch get the 100% scholarship on plus subscription. And 100 winners from each branch will be given additional discount like 50%, 70%, 75%, 80% like that. And the exam duration is 60 minutes, 1 hour. Duration of the exam is 1 hour. The exam will start on 11 AM Sunday. Okay, during that, using my code to unlock the exam, use my code VROW10. Now here in this combat you are getting these things. You are going to writing the India's largest weekly scholarship test for GATE, and you can assess your GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators, and you can take it live to compete with the best, and super fast and fun with all India live leaderboard, and you can identify and improve your weak areas through detailed video solutions. Okay, and the next combat is on coming Sunday 25th April, starts at 11 AM. Don't forget to use my code VIRAO10. So GATE 2021 rankers who benefited from GATE comeback. Yeah. Now our topic is common source amplifier with source resistance. Last session we complete the common source amplifier. Now this session we are going to whatever the bypass capacitor at source terminal of the JFET, we are going to removing that. Okay, so now it is common source amplifier without bypass capacitor. Common source amplifier without bypass capacitor. Okay, without bypass capacitor. Now first I am going to the circuit diagram. Source terminal we have RS, at a drain terminal we have RD, and biasing resistors input side R1 R2. Now plus VDD, this is the gate terminal, source terminal and drain terminal. Common source amplifier, in general for common source amplifier we are connecting a CS capacitor, external capacitor to ground from source 2. Now this is common source amplifier without bypass capacitor. This is our bypass capacitor. Okay, now I want to analyze this without this bypass capacitor. Okay, so I am going to removing this bypass capacitor. That's it. No bypass capacitor. Now at input side I am going to connecting the input, gate connected to input, at drain we are taking output. Okay, here we are using capacitor, it is CD, CS, CG. Now the names resistors are R1, R2, RD. Okay, this is the circuit diagram. Now we need to take to analyze this we need to take the AC equivalent of this circuit. Okay, AC equivalent of this circuit. Now I am taking AC equivalent. See this, here I am taking AC equivalent. Okay, this is AC equivalent. AC equivalent. AC equivalent. For AC equivalent, all capacitors are short circuited, and whatever the DC supply here we have, it is connected to ground. VDD connected to ground. Now R1 and R2, R1 R2 both are parallel from gate connected to ground through R1 and R2. It means both are in parallel, and drain connected to ground through RD. source connected to ground through RS. Now I am taking that circuit. Now next level of equivalent circuit is source, drain, input side we have a gate. Okay, now gate connected to ground through R1, R2. R1 and R2. Source connected to ground through RS. Drain connected to ground through RD. Now at a drain we are taking output. At gate we are applying input. At the same time, whatever the R1 and R2 we have, I am taking that parallel combination as RG. R1 parallel with R2. Okay, now its equivalent circuit is so at gate we have RG. We are giving input. This is the final AC equivalent circuit. RG, RS, RD taking output. This is the drain and this is the drain current ID. Sorry. Okay. So this is the final AC equivalent circuit. Now I am going to replacing your FET by its a small signal equivalent. Replacing FET by its a small signal equivalent. Now this is ID. Replacing FET, this FET by its a small signal equivalent. If you observe, this is going to be the gate terminal, source terminal and drain terminal. Okay, replacing this FET by its a small signal equivalent like this. And one more, I am going to omitting the, for my easy understanding purpose, I am omitting the effect of that channel length modulation effect. Okay, now okay, are considering it's not an issue. This is gate, source, this is RD, drain, this is the source terminal, which is a GM VGS and this is the voltage VGS. Now give the external connections to this. This is our source terminal. Okay, now I am removing this part. This is source terminal. Now source connected to ground through RS and drain connected to ground through RD and gate connected to ground through RG. Here you are applying input. All these are ground. Okay, and we know one more thing, this is your ID, this is minus ID, The current through this one also ID. Okay, this is ID. Now current through this one is only current through this part is ID minus GM VGS, and voltage between these two terminals is VDN, drain to neutral voltage. This is nothing but your output voltage. Output voltage is VDN, drain to neutral. This is the neutral terminal, ground. Okay, now this is your input voltage. Now the voltage between these two is VGS plus ID into RS. So which is VGS plus ID into voltage between these two terminals I am taking. It is nothing but a voltage between these two plus voltage between these two. Here to here voltage plus here to here voltage. ID into RS. ID into RS. Okay. So this is the circuit so far what we have. Now I am going to using this circuit. Okay, next we write that because I want to copy the circuit. Now using this circuit to analyze this. Yeah, this is your input. Now input can be written as VGS plus ID into RS. Okay, and VDN is voltage across small rd plus voltage across RS. Okay, which is equal to minus ID into RD. Therefore, V output voltage is minus ID into capital RD. At the same time, VDN is ID minus GM VGS into small rd plus ID into RS. Okay. Now here we need a relation between VDN and we need VDN by V input. VDN is nothing but a V output voltage. VDN by V input. So in that VDN by V input, here we have ID GM VGS. Here also ID VGS. Okay, simplify this. Now I am going to equating this. Therefore, V input is V output is minus ID into RD. Okay. VDN ID into RS. Okay, fine. Okay, just simplify this. VDN is ID into RD plus RS minus GM into RD into VGS. Okay. Now you are saying this is VDN. Now I am going to equating this is nothing but a minus ID RD. Therefore, which is equals to minus ID into capital RD. Now simplify this from this. Take this one this side. Therefore, take this one this side and this one this side. GM into RD into VGS equal to ID into capital RD plus small rd plus RS. Okay. Now from this I am going to getting the value of VGS by ID, which is capital RD plus small rd plus RS by Gm into small r. Next use that equation, and from this I'm going to be dividing this one with this, and it is, you can write this is ID times small rd plus RS minus Gm into RD into VGS. Okay, now I am taking this ID common here. Now once taking the common ID, from this we can write VGS. VGS is, or take the ID. ID is Gm into RD by capital RD plus small rd plus RS into VGS. Now take this ID value and substitute here. Therefore V input is VGS plus ID into RS. But just before we calculated ID, your ID is Gm into RD into VGS by capital RD plus small rd plus RS. Substitute this one here. Therefore V input is VGS plus ID value Gm into RD into VGS by RD plus RS plus small rd into RS. Just to take VGS common. By taking VGS common, it is 1 plus Gm into small rd into capital RS by RD plus RS plus capital RD. That is the value. This is the equation for input. Similarly, take the output. We know the output value. V output is nothing but a VDN, which is minus ID into capital RD. We can define it. Okay. Now substitute this ID value what you have in terms of VGS, substitute here. Therefore, it is minus ID value Gm into RD into VGS into capital RD by RD plus RS plus small rd. Okay, this is the V output. Now gain is V output by V input, this one by this. Therefore voltage gain is, see, current gain is infinity, input impedance is infinity, no need of it. We need just voltage gain and output impedance. Voltage gain is V output by V input. Just before we got V output is minus Gm into VGS into small rd into capital RD by capital RD plus small rd plus RS. This is the output voltage what we get previous case. This one minus Gm into RD VGS RD by RD plus RS plus small rd. Similarly, from this input is VGS into 1 plus, so VGS into 1 plus Gm into small rd into RS by RD plus capital RD plus RS. Okay, So this is the value. Just to simplify this, now by simplification, is a VGS gets cancelled. First of all, here just take the LCM and these two gets cancelled. After that, which is minus GM into RD into capital RD by GM into RD into RS plus small rd plus capital RD plus RS. Taking the simplification, now here it is. Just take the RS common from this. Okay, by taking RS common is greater. I do one thing. I am taking capital RD plus small rd common. Now it is minus GM into small rd into capital RD by small rd plus capital RD into 1 plus, in this two I am taking RS common, RS into 1 plus GM into RD by small rd plus capital RD. Now this is going to be, this part is minus GM into RD parallel with capital RD. So which is minus GM into small rd parallel with the capital RD by 1 plus here we take an RS common. Okay. Now see RS into, okay, now RS by RD plus capital RD into 1 plus GM RD. Here I am taking one analysis, one assumptions. Now here is RD is much greater than capital RD. So from this RD plus capital RD can be written as approximately capital RD, and at the same time GM into capital RD, because RD is very high, because of this it is much greater than 1. Now from this we can write 1 plus GM into capital RD as approximately GM small rd. I am writing these assumptions on this. Now therefore voltage gain is minus GM into capital RD parallel with small rd parallel with capital RD by 1 plus RS into GM into RD by these two replaced by small rd. Okay, now these two gets cancelled. Okay, therefore voltage gain is minus GM into small rd parallel with the capital RD by 1 plus GM into RS. 1 plus GM into RS. See, without this bypass capacitor, with the bypass capacitor, we are bypassing the effect of RS. Once we are removing the capacitor, it is by 1 plus something. Now the gain is decreasing. Gain is decreasing. So it is 1 plus GM into RS. This is the final voltage gain. Approximate values are, it is not much variation, but even though for approximate and exact, not much variation. Okay, this is the voltage gain of this. Okay, now so this is the way of calculating the voltage gain. After that we go and calculate the output impedance. So for output impedance, I am taking the equivalent circuit. See this? This is the equivalent circuit I am going to be taking. In this external load, what we have, I am going to be disconnecting this and making V input equal to 0. Okay. Now I'm taking that circuit. So gate, here we have RS, small rd, GM VGS, RG. This is V input. Here it is a drain. Now whatever the load RA, capital RD, external RD, I am disconnecting that. RD. This is your ID. This is VDN. Now output impedance is written as VDN by voltage between output terminals by current ID at a condition of V input equal to 0. V input 0 in this sense, it is connected to ground, simply ground. So once all are short circuit. Once it is grounded, now it became VGS minus plus VGS, and the current through this one is ID. Okay, under these conditions I want VDN by ID. Now I am writing VDN. At the same time, the current through this one is ID minus GM VGS. Now by applying KVL to output loop, we get VDN equal to ID minus GM VGS into small rd plus ID into RS. Okay, and from this we can write VGS is equals to minus ID into RS. Now in place of VGS, substitute this. Therefore VDN equal to ID into RD plus RS minus GM into RD into VGS. VGS is minus IDRS. Therefore VDN is ID into RD plus ID into a minute. Okay, ID minus RD plus ID into RS. Fine. But IDRS is, it is minus VGS. Okay, minus VGS. This is VDN. VDN is ID times small rd plus capital RS. Okay, minus GM into VGS to small rd. Okay, fine. Now VDN is ID into RD plus RS minus to minus plus GM into RD into RS. Okay, GM into RD into RS into ID is there. Therefore VDN by ID is RD plus Rs plus Rs into 1 plus Gm into Rd. Okay, therefore output resistance is small Rd plus Rs into 1 plus Gm into Rd. Now R naught dash is capital Rd parallel with R naught. Okay, this is R naught dash. This is R naught dash. So the output impedance of this amplifier circuit is R naught dash. Output impedance of device is R naught. Output impedance of device is different from output impedance of amplifier, including biasing resistor, that is the input and output impedances of that amplifier. Without biasing resistors, that is the input and output impedance of that device. Okay, at input and output terminals. So this is about your R naught, and we know that current gain is infinity, no doubt, and input impedance also infinity. Okay, this is about the circuit. Common source amplifier without bypass capacitor. Now here we go and do the little bit analysis on common source stage by using a MOSFET. Okay, now see, generally whatever the thing you are applying to JFET, for MOSFET also you are applying same formulas. Why? Because for both the conditions small signal equivalent is same. Okay, same biasing resistors we are using. Okay, now here whatever the amplifier, just before we studied a common source amplifier, I am going to be operating that common source amplifier with different loads. Previous conditions you observed in this circuit. Here this is RT, this RD is acting as a load. Now I am going to replacing this one by a current source. After that I am going to replacing this a diode connected transistor. Under that conditions, what is the gain? What is the output impedance? Now I am going to check this. Now, first of all, current sources, realization of current sources. First you should know what is a current source. Current sources. By using MOSFET, you can design a current source. Okay, now first I am going to designing that by using NMOS. Next we are going to design it by PMOS. By using NMOS, source connected to ground, drain is connected to some point, let us take it as X. Here is input or biasing voltage. VB means biasing voltage. Okay, it can be represented by a current source, and this biasing voltage taking this transistor into saturation or pinch off region. Now it can be represented by simply a current source. Current source. Okay, this is the current source. This is the point X. Now you can replace this one by its current source. Similarly, here in PMOS, proper biasing voltage I am connecting. let us take this is the point Y. Here we are connecting to this is VDD. This is the biasing voltage. Now we can replace it by again a current source, but it is starting from supply. This is the terminal Y. Here it is VDD. After this you can connect some circuit, and here you can connect something. Okay, this is the realization of current sources by using MOSFET. Okay, now I'm going to using this is the load in common source amplifier. Okay, I'm replacing your common source amplifier with load. Now it is CS stage, common source stage with current source load. So you can expect this type of problems in your GATE exam. Regular common source, common drain, common emitter amplifiers, common gate amplifiers is over. This part is over. Now you can expect these things with current source load, common source stage with current source load. It means like this. Circuit is like this. Okay, now this is the case. This is the regular device. Here I am applying input voltage. This is biased MOSFET. VB biasing voltage. Sorry. This is the VB and it is P channel MOSFET. VDD. Okay. And here we are taking output. And you observed or not, this is nothing but a current source. Okay, this is your current source. Okay, this is your current source. Okay, this is your current source. Now I'm going to replacing this MOS device by its small signal equivalent. I'm doing that one here. So here is source, here is the gate. Gate in small signal analysis, biasing voltage connected to ground, so gate connected to ground. Okay, and after that this is the source, this is also connected to ground. It is the source, drain and gate. Source connected to ground, this is the source, this is the gate. Okay, so between this gate to source we have VGS, and after that there is a gate current is 0, that's why it is open circuited, and here is your small signal equivalent, and it is connected to R0, output impedance of this, or you can call it RD. This is let us I am taking M2 device 2, M1 device 1, so I am taking this is VGS2, okay, and it is current is GM VGS2. This is R0, okay, let us take it as R02, output impedance of this, that's it. Okay, it is connected to, okay, it is already connected, source terminal, it is connected to ground, thing to connect here. Now this is drain terminal, so drain is connected to the output here, output, and here we have the device like this, and the device what you are using, okay, the output impedance between the output terminals is R01. R01 is the output impedance of this. Now you observed or not this circuit, I do a little bit analysis on this, and for that I am copying this circuit. Now see this, in this circuit you observed or not, this is grounded and this is grounded, that means VGS2 is 0 volts, it is ground. Now GM VG2 it is, once it is 0, this is also 0, it is open circuited, and this part is connected to ground. Now its equivalent circuit is like this. Here is output impedance of this one R01, and output impedance of this one is R02. Both are parallel. Here we are taking output. Okay, V input. Now already, now it seems to be a common source amplifier. Common source amplifier gain is minus GM into load. So its voltage gain is now minus GM into, this is a device M1. So device minus GM1 into R01 parallel with R02. R01 and R02 are the output impedances of MOS device M1 and M2. Or it is equal to RD1 and RD2. Here R01 is equal to RD1 and R02 is equal to RD2. Okay. Now that is the voltage gain. Okay. This is using replaced your this is by using E-MOSFET, N channel E-MOSFET. Now using P channel device, the circuit is like this. Now the same thing using P channel, using PMOS. So here PMOS is the driving device. So input applying at PMOS, and load is, current source is NMOS. This is the biasing voltage VB, V output. Now voltage gain of this one is no doubt, which is minus, let us take M1 and M2 device. The main device is M1, so now it is GM1 into R02 parallel with R01. That's it. You should practice such type of some standard circuits. Okay, and these equations should be noted. Then only you can save the time in your examination. Okay, this is about common source amplifier with current source load. Okay, next. Now I am going to common source stage with the diode connected load. With the diode connected load. Next one is common source stage with the diode connected load. Diode connected load. Now, here, see this circuit. Here, I am applying input. Is ground, so it should be NMOS, and it is PMOS. Sorry, it is also NMOS, and it is connected to supply. Diode connected. This is called a diode connected MOS transistor. Diode connected MOS transistor. This part is diode connected MOS. This is diode connected load or diode connected MOS. Okay, and taking output here. Taking output here. Okay. Now, I am going to replacing this MOS by its here I am going to replacing this by its small signal equivalent and taking the gain of it. Okay, so first I am taking let lambda is 0. That means omitting base channel length modulation. By taking lambda 0, you can take your MOS device. Let us take it is M1, it is M2, and we can take this is like this. GM into VGS1 connected to drain, drain connected to ground. Why? Because it is connected to VDD, and here is the source, and here is gate. Gate also connected to ground because it is connected to supply. Gate is connected to VDD, same. It is also connected to ground. This is VGS source it is. Okay, and this is your ID. So now your device is like this. Here we are taking output. Now here what I am doing is I am going to calculating the output impedance of this circuit in this point. Output resistance at this point I am going to be calculating. Okay, so that is a R0 M1 device, so I am taking it as R01. That is, I am taking it as small R01. Okay, R0. capital R, because if I take it as a small r, then there is a chance of misunderstanding. It is a dynamic resistance, drain resistance. Okay, now I'm going to calculating R naught. So R naught at this end is nothing but a voltage between these 2 points by current. Okay, now this voltage is let us take Vx, and this current is some Ix. Now I am copying this circuit for analysis. Yeah. Now in this circuit, it is Vx and it is Ix, but Ix is nothing but a minus ID. Okay, Ix is nothing but a minus ID, and that minus ID is minus Gm into VGS1. Okay, and see this, it is connected to ground. So here the voltage at this point with respect, we need voltage at this point with respect to ground, that is Vx you are calling, but voltage at this point with respect to ground is minus VGS. Therefore Vx is nothing but a minus VGS. Now we can write Ix is minus Gm into VGS1 is minus Vx. Therefore Vx by Ix is R naught, which is 1 by Gm1, first device. That is output impedance of this. Now once you calculated output impedance, we can replace this total part by its output impedance, R now 1 by Gm. Okay, so now it is V output. This is a plus VDD. Now the impedance between these two is 1 by Gm1. It is M2. Okay, now if you consider the output impedance of this one is R01. Now the voltage gain of this one is minus Gm2 into R01 parallel with 1 by Gm1. That's it. Minus Gm2 into R01 parallel with 1 by Gm1. Is it okay? Is it okay, sir? Now, so sorry, we do one more. We omitted this a lambda, that's why R01 also I am going to be omitting. Then it became so it is M2. Now voltage gain is minus Gm2 into 1 by Gm1. Since lambda is 0, we are assuming lambda is channel length modulation parameter is 0, and we know the transconductance values Gm1 and Gm2. We know the Gm value. Gm2 is 2 into mu n cox into W by L of 2 into whatever the drain current it has. But both the devices are in series, that's why both are maintaining same drain currents. Mu n cox into W by L of 2 into ID. Sorry, it is W by L of 1. Gm1 it is, so that's why. So now after simplification, it is W by L of 2 by square root of W by L of 1. That's it. See how simple it is. Okay, now if lambda not equal to 0, then the equivalent circuit is, that means we are considering the channel length modulation only, that is the difference. In that case, the equivalent circuit is here we have 1 by GM1 already. Okay, and it is connected already ground, and here we have output impedance of this RD2 or R02. Okay, sir, R01 taking output, here input applying, and there is output impedance of this between output terminals, that is R01. 2 it is because it is device M2. Now voltage gain is minus GM2 into these two parallel, and this one is parallel with this 1 by GM1 parallel with R01 parallel with R0. That's it. See this, how simple we can design it. And therefore output impedance of this circuit is, except GM, remaining is output impedance 1 by GM1 parallel with R01 parallel with R0. That's it. Okay, like this we can do the analysis on these circuits. Okay, this is about your common source amplifier with diode connected load as well as current source load. Here are the some of the top educators from Unacademy. Tiwari sir, he is IIT topper. IIT topper. He has 7 years of GATE and engineering service examination. Sanchit Jain sir, he is the computer science faculty having experience more than 8 years. Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical, and he was awarded President of India Gold Medal in IIT Indore. Jaspal Singh sir, he is ex-IAS officer, he got 4th rank in that, and he is the ex-senior faculty from GATE ESE. These are the few more top educators from Unacademy. These are the different engineering services, GATE and engineering service exams, which are available in Unacademy for GATE and engineering service. So there are 2 subscriptions already mentioned, Plus and Iconic plan. In these 2, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. Okay, and in Iconic plan, once your test is completed, your test it is forwarded to personal coach. Personal coaches do the personal analysis on that, and they prepare a study plan and respect to study material they will provide to you. By following this, every student can get success. In Plus plan, these are the different subscriptions available and respect to cost, and by using my code VRAU10 during subscription, you get it by 10% discount. Similarly, in Iconic plan also different subscriptions, 1 year and 2 years. By using my code, you get 10% discount. And don't forget to use my code VRAU10 and subscribe us. Hit the bell icon for getting notifications. Please give your valuable comments on YouTube and join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Thanks for spending your valuable time with us.